Well, good morning, wonderful people. Let's get started. All right, so we're going to do standard form and slope intercept form. So by the end of this lesson, you will be able to graph functions using standard form, graph using slope intercept form, find linear functions x and y intercepts, and graph algebraically using them. Determine if a pair of lines are parallel, perpendicular, or neither. Okay, so linear equations. So linear, so from the last lesson, it would be straight lines basically, right? You have straight lines, that's called a linear relationship. So linear, the root word is line, so it's like line ER, just means line. So linear relations can be represented by an equation. For an example, here on the picture to the right, we have x plus y equals 8. So it crosses at y equals 8 and x equal 8. And all the points in between there would, would land here if I had, like, say, x of 6 and y of 2. 2 plus 6 would equal 8. And it goes for all of these points along the graph. And this is what we call standard form. So when we write something in standard form, that means it's going to be in the form of ax plus by equals c. So that is the way standard form is written. And that's different than the other forms because you have both of them are intercepts. And it's also different it comes with a couple of rules. So A, B, and C are integers, meaning that they cannot be like 4.2. They cannot be decimal numbers and they cannot be fractions. So keep them whole numbers, whether they're positive or negative, except for A though. There is a rule with A, and that is A has to be positive. So you cannot have like a negative number on A basically. And the greatest common factor of ABC is 1. Basically, it means that if you can divide all three of those by a number, then do it. It's kind of like dividing fractions. I'm sorry, not dividing fractions. It's more like simplifying or reducing fractions. There you go. That's what I meant to say. It's more like reducing fractions. But you got to check with all three of these numbers, A, B, and C. So let's go ahead and practice writing some of these in standard form. So write each equation in standard form. So with this first one here, we got to check, make sure that we follow all the rules for standard form. So A in this case is negative. So we have to make it unnegative. So let's go ahead and I'm going to multiply everything by -1. So that's basically just going to flip the sign of everything. So negative 5x is going to be positive 5x. Positive 6y is negative 6y. Negative 12 is going to be positive 12 or regular 12. So there you go. Now my a value is positive. And it doesn't matter what the other one's signs are. And it also has to be in the correct order. So x, y equals number. X, y equals number. So this one is in the correct form. Nothing else. So 5, 6, and 12, we can't divide those three numbers by any other number, so we just leave it like that. So that was a pretty easy one. Let's go ahead and get to the next one. So y equals 2x minus 9. Now this is a linear form, but it is not standard form. So we are going to have to change a couple of things. So I'm going to go ahead and minus 2x from both sides. And there's a couple of different ways you could do this too, but I'm going to kind of stick with the way that I think more people would be familiar with. So negative 2x. So I want the x to go first. I could easily write it as y minus 2x. But I'm trying to make it look like the ax plus by equals c. So x, y, and that should have been y, equals -9. And now we run into that same problem as the first one, where we have the first term, our a value, is negative. So we got to fix that. Multiply everything by -1. And basically, again, that's just going to reverse the sign of everything. Negative times negative is positive. So there we go. Now it is written in standard form. And there are no numbers that 2, 1, and 9 can all be divided by. So that's it. And I don't know if there's really a best way to do this. Not like making the rules of equations right here. So with the rules of equations, you know, you can follow the same steps each time. But with this, there's not really any steps you can do. So I guess first thing we can do is make sure it's in order. So x, y, and it's supposed to be equals number. But here, the equal sign and the c value are switched. So I got to just minus, well, I got to get rid of this 24. So minus 24, do the opposite. That's going to be add 24. 9x plus 6y. So off to a pretty good start. Now 0 plus 24 is going to be 24. And there we go. X is positive. It is in the correct order. So x, y equals number c. But there is one other thing we could do, and that is we have to have all of them with the greatest common factor of each other, right? So 9, 6, and 24 can all be divided by 3. So we're going to have to divide everything by 3. So it's kind of like I said, it's kind of like simplifying fractions, but there are 3 numbers, right? 9, 6, and 24. We got to make sure that they all can't be divided by any of the same numbers. So 9 divided by 3 is going to be 3x. Oops, go ahead and change that. So, oops, 3x plus, and then 6 divided by 3 is 2, so 2y, and 24 divided by 3 is 8. Now at this point, 3, 2, and 8 have no numbers that they can all be divided by, so that's in simplest form. It is in order, and it has the a positive. Okay. I'm going to go ahead and move on to this one here. Now, again, we don't have to do any specific order, but I'm sorry, we don't have to follow any steps to get them in order. But in this case here, it kind of bugs me that they're all 7. So I'd like to divide all of them by 7 first, but I'm going to go ahead and ignore my urge to divide everything by 7. And I'm going to go ahead and move x over to this side. So I'm going to move all my variables to the left side, which is, again, that's the way variables should be on the left side. 7x plus 7y equals 7. Now we can go ahead and divide everything by 7. And now, if I divide everything by 7, x plus y equals 1. And we're done with that one there. Okay, now we have these ones with fractions, and these ones are going to be a big headache. But, you know, we can use that same thing we did. Oh, gosh, I don't remember exactly which lesson it was, and I could tell you how many days ago we did it. But when you have fractions like this, what you do is you look at the bottom numbers. So my bottom numbers are 4, 3, and, well, this one here would be 1. But since there's nothing there, we can go ahead and ignore it because 1 divides by anything, or anything can be divided by 1 and still be the same number. So I want to think of a number that can divide by 4 and divide by 3. Which there's only one number that should come to mind, and that is 12. So I need to multiply everything by 12. Now I have a little bit of space here, so I'm going to skip a few steps. So 12 over 1, if you want to, you know, multiply top number to top number and bottom number to bottom number, but your bottom number is going to be 1 anyway, so we can just ignore that. 12 times 3 is 12, 24, 36. So 36 divided by 4. So 36 divided by 4 is 9. So 9x. And again, you could write all these steps out, and I would suggest that you do, but I'm going to run out of space here. And if I wrote any smaller, if you're watching this on your phone, you probably won't be able to see the numbers clear enough. So 12 times 1 is going to be 12. Then divide it by 3, so that'd be 4y equals, and then last number here is 1, so 12 times 1 is 12. And there you go. It's in the correct order, x, y equals number. The first term is positive, and we have no common numbers that we can divide all of them. Say, like if this was 3 here, 3y, then we could divide everything by 3, but it's not. So works out. I guess I could have wrote that last step, come to think of it. Oh well. Could have wrote the step in the middle. So in this case here, I'm going to multiply everything by 6 now, because again, I want to get rid of this fraction. And this multiplication by a number only works if you have an equal sign. All right, it only works if you have an equal sign. If you're going to be adding or subtracting expressions with fractions, then you're going to have to use a different thing. You're going to have to make sure the bottom numbers match. But if you don't know how to do that, that's fine. For this one here with equations, just multiply it by 6. So 6 times 1/6, right? If you have 1/6 and 6 of those, that's just going to be 1. So keep everything where it is, just multiply everything by 6. So 6 times y, and -2 times 6 is -12. And I just need to move this y from here to here. X minus 6y equals -12. There we go. We were able to put all of these into standard form. Standard form is not really used all that much in linear equations, but it is worth going over. And again, this is mostly review because most of you guys have done Algebra 1, although it's a little bit different for everybody because some people have had a very some people have had it more recently than others. So linear equations are oftentimes written in slope-intercept form. For slope-intercept form, that is y equals mx plus b, or as I like to say, yesterday I made excellent bacon, or excellent breakfast, whichever one you prefer. And yesterday we learned a little bit about function notation, so let's go ahead and put this into function notation. So y equals mx plus b is put into function notation by taking out the y, replacing it with f of x. And again, that just means when the input is x, the output is whatever's on the other side. Now in both of these, m is the slope, and that means the kind of like the pitch of the line. So as the line's going, this way, is it going down or is it going up, right? And you always look at it in terms of left to right. And this here would be the y-intercept, is the b value. Or if you remember what I said earlier, there is that thing I just said, and that is, yesterday I made excellent bacon, or excellent breakfast, whichever one you again prefer, because most people eat bacon for breakfast, and if you don't eat bacon for breakfast, then I don't judge. I like bacon in hamburgers and sub sandwiches. But B is where it begins. So you begin your day with bacon, or you begin your day with breakfast. So here we have different kinds of slopes. We have, well, 4 kinds of slopes. And I just got done writing all of them while I was talking about the way to remember y equals mx plus b. So there's positive slope. And like I was saying, if I were to have a graph for each of these. All right, these are not the best graphs, but hopefully they'll be enough to help you understand the point. So again, moving from left to right, a positive slope means that it goes up. It's going up. If you imagine like a person running along this line, running to the right, they are going to be going upwards. If they are running on this line, they will be going downwards. So again, it always goes left to right, negative or positive. And then there are zero lines. A zero line, now in this case again, it's just because of my graph, it doesn't quite work out the same way. Zero lines are perfectly horizontal. They don't really have an up or a down pitch. They just sort of run parallel to the x-axis. And then there is the last kind, which is an undefined slope. So why is it undefined? If you remember when we were talking about real numbers, there were some numbers that I kind of mentioned that weren't written, but I mentioned them, and that was undefined numbers and imaginary numbers are not real numbers. So with an undefined slope, it's just like undefined. If you take any calculator, if you have a calculator in your pocket or on your computer or whatever you're watching this on, type in 5 divided by 0. You're usually going to get something that says undefined, cannot divide by 0, error, or something like that, because you can't usually divide by 0. It's just one of those things that doesn't happen. It's not really a valid operation. It just, again, just doesn't work. Okay, so here it's asking us to put the equation in slope-intercept form and then graph it. So we're just gonna have to do a little bit of moving around with the, well, in this case, this one's already, it's already there. We don't need to worry about anything else. It's already in y equals mx plus b. Y equals mx plus b, or yesterday I made excellent breakfast. So I'm gonna go ahead and move into 7, which I think 7 is right there. So again, b is for begins. So b is 7 and m is 2/5. And if your m value is a fraction, that actually works a little bit better because it shows your rise and your run. Now be careful, because rise can also mean it goes down. I know when people think of the word rise, they think it means go up. But that's not really true in this case, because rise can be negative, which if you have negative or opposite of rise, that means going down. But in this case, it's positive, so it's going to be going up 2 over 5, which is somewhere over here. But I'm going to show you another trick too, and that is if you ever have something like this where you cannot graph it because it's off the graph, you can make them both negative, because if you remember, one of the other rules is negative divided by a negative is positive. So it should still have the same slope. So my rise is negative, so down 2, and my run is negative, so I go backwards. Like I said, imagine a little video game character running to the right. Because as far as I know, nearly all platforming, side-scrolling video games I know of, your character is always running to the right. Which is kind of a weird thing too, I guess, because in other countries, they still run to the right. And I know of very few where you run to the left. I'm not sure if there's any reason for that, but I don't know. Even in cultures where writing is backwards, they still play their video games moving left to right. All right, so here in this one here, we have the same thing. So look at my line. The B is for begins, right? So my line begins here. Now, it doesn't actually begin there because it comes from negative infinity to positive infinity. But if we think about writing the line when we're constructing the line, then it starts there, right? So again, that's where our line begins. And then now we have to determine where it's going, which direction it's going. And in this case, we only have one clue, and that is m equals -1. Now, if you have a slope that is a whole number, you can turn it into a fraction by putting a 1 under it. So there you go. Now I have a rise of -1 and a run of 1. So this means down 1, right one, down one, down one, right one, down one, right one, down one, right one, all the way down. So I get a perfectly diagonal line. And I just need some kind of straight tool. If you have a ruler, that works better. Something that you can make a nice straight line with. And when you're drawing these lines, make sure you go from one corner of the graph, so one edge or side of the graph, all the way to the other side, because this line goes on and on forever in both directions. So if you remember, I don't know if I still have my Desmos from yesterday. I think I do actually. So these lines, if I were to get it, remember, they go on and on forever. They do not end, they do not stop. And anywhere I look at the line, it goes from the top to the bottom, or if I'm having a sideways line, it goes all the way from one side to the other side. So make sure when you're drawing these lines, you make sure the line goes all the way across. All right, now it looks like I'm gonna have to do a little bit of work on this one here because it's not in slope intercept form. Now you can still graph this in standard form, but you know, I'll be kind of honest with you. Not very many people really graph in standard form. It's just not all that common. I mean, I'm not saying people don't do it, because plenty of people will do that, and there are plenty of lessons where people will do that, but it's just not, again, not that common. All right, so after I move x to this side, because I want to get the y by itself, to get the y by itself, I got to get rid of the 3, so that means divide everything by 3. Now remember, in front of this x, there is a 1. In front of any variable, there is always a hidden 1. Now I want that to be a fraction, and I don't want the x to necessarily be involved, so I'm going to make the x jump off. So it's like a table, it can just jump off of that if it wants to. Now I can see both of the pieces I need to make my graph. So my graph begins at -5. Make sure I have, there you go, -5. And now I need to find the slope, which is down 1 over 3, down 1 over 3. And I just need enough dots, I need enough points to get an idea of where the line is going to go, and then I do my best to draw a line through all of those points. Now for this one here, we just got to put it back into slope intercept form again. -4x, so I'm going to minus 4x from both sides. And it looks like I'm gonna have to do some other stuff too. While I'm here, I guess I can also add 1 to both sides. Now remember, I got to do it to both sides of the equal sign, so that way they both move over to the other side. And hopefully this will get the y by itself, which is good because in this case I don't have anything with the y. So there we go. It was pretty easy to solve that one because I didn't have any other y's, which means I don't have any other steps. On this side, I only have -4x plus 1, right? And combine that with 0, and it's going to be the exact same thing. I'm not going to change it. All right, -4x plus 1. So again, that b value is where it begins. So we begin our line at 1. And we could make this a fraction. -4 is a fraction, which is always a good thing because sometimes students, they think that if it means down 4, down 4, down 4, which no, that is not, that's not how it goes. It's down 4 over 1, down 4 over 1. That doesn't quite look like a 1. It kind of looked like a 7 there. And now I should be able to make my line. And again, just draw this, and I don't want to see any of these lines too. These things bug me more than they should, but they still do. And that's because, again, lines don't just stop. All right, lines go on and on forever. So make sure it goes from one side of the graph to the other side of the graph. If you have little tiny weak lines, all right, no, that's not the way lines are supposed to be. And so there you go, we graphed all of those lines. Let's move on to the next thing. So again, that's pretty easy. But there are some other cases. If you remember from yesterday, sometimes there are special cases with lines, and we had two of them yesterday. If you remember yesterday when we were going over functions and we had to determine the domain and range of certain numbers. So you can't quite see them here, so maybe I'll just go over them so you can see them a little bit better in color. So we have a line there, and we have another line here. And here it says write an equation for the line on the graph. So in this case here, one easy way that you can remember this is if you are missing a letter, then your line does not touch that axis. So if we have y equals mx plus b, we should not have a y, because see how it doesn't touch the y-axis? So that means we only have x equals -3. So x can only be -3. If I go y of -4, it's going to be -4, 3. If I go y of 2, up 2, back 3, it's always going to be, x is always going to be 3 no matter what. And again, there's no y value in this one. Now for number 12, we have no x value, because you see that our line runs parallel to the x-axis, which means it's not going to cross, meaning if we go forever in both directions, if I showed you my Desmos graph and we graph that, it's going to run parallel, which means it's never going to touch the x-axis, which means there is no x number. So in this case here, y just equals 1, and y is always going to equal 1. If I put in 4 for x, y will be 1. If I put in -2 for x, y will also be 1, and it's true like that forever in both directions. Okay, so for this one here, let's go ahead and look at types of lines, and there's first one is parallel. So what kind of slope do parallel lines have? So the slopes of parallel lines are equal. So they are pretty much the same. If they have the exact same slope, that means they run in the exact same direction, which means that they will not cross each other or move away from each other. Slopes of perpendicular lines. So perpendicular lines, now if I was in a classroom and I showed you, a perpendicular line is one where you have 90-degree intersection. So I could show you two lines and put a piece of paper there and show you that they are indeed perpendicular. So in order to be perpendicular, they have to be opposite. So if it's negative, the other has to be positive. If the first is positive, then the other has to be negative. They are opposites and reciprocals. Opposite and reciprocals. They have to be both of those things. And reciprocal in this case means flipping the number as a fraction. So with some of those other ones where we were graphing them, just take those fractions and flip them. So bottom number becomes the top number and top number becomes the bottom number. So now we're going to have to look at some lines and tell whether they are parallel or perpendicular. Okay. So determine whether these are parallel, perpendicular, or neither. So there's a good chance that they could be neither of them. So we're going to have to do the same thing we did before and put them into slope-intercept form. Now, slope-intercept form is oftentimes the most favored way to graph something because you can tell a lot just by looking at it. You know, you can tell where the line will intersect the y-axis, and you can also tell what the slope is. And in this case, it's very helpful for us to know what the slope is, because if we know the slope, we can compare them and see if they are the same or opposite reciprocals. Okay, so there you go. I got my first one here. So negative 10 divided by 5 is going to be 2x plus 1. Now, in this case here, this is the only thing I'm looking at. All right, negative 2, that's the only thing I'm looking at. I don't care about this one here. Well, in this case, I guess we could care a little bit if we were looking for what we have as the same line. But I don't think there's any option of the same line, so I think we're pretty much good. Now for this one here, just to make things easier, I'm going to use reflexive property because I don't want to move that 2. Because if I move the 2, well, okay, if I was trying to put it in standard form, I'd move the 2, but I'm trying to put it in slope-intercept form. So I'm trying to get that 2 by itself, trying to get that 2 off the y so I can get the y by itself as fast as I can. Now, if I look on this side here, I have negative x and negative 16. Okay, now I got to divide everything by 2 because I still got to get that y by itself. So solve for y. Y equals, so I have my second graph. So this is negative 1 over 2x. And 16 divided by 2 is 8. So negative 8 is the last number. And there you go. Now I have them both in slope-intercept form. I can look at their slopes. So my first slope is negative 2x. And this one is negative half x. Now that second one is reciprocaled. Because remember, we got to turn this into a fraction. So put a 1 under it and flip it. So it becomes 1 over 2. So they are reciprocals. However, they are not opposites. They are both negative, which means they are similar, not opposite. Since they're both negative, they are neither. Okay, that's like the worst handwriting ever. I just kind of stuck it in there as best I could. All right, so let's go to the next one. Let's see, I got to get y by itself. Now, again, me knowing some of these tricks, I can kind of get it a little bit faster, but I'm gonna add 6y to both sides. Or actually, you know what? Let me think about that. I think it might, it might be easier or faster to minus 8x from both sides. So minusing 8x, I get negative 6y equals, and again, I could say 42 minus 8x, but I'm trying to make it look like the y equals mx plus b. So everything you do should try to make it look closer and closer to y equals mx plus b. And then lastly, I need to get rid of this 6, but now I have to divide everything by negative 6. Now, if we were using inequalities, it would be more helpful to flip the sign right now, but we don't need to worry about that. We're not working with inequalities. So I'm going to simplify this fraction. So instead of 8 over 6, I'm going to simplify it to 4 over 3. Also, negative divided by negative is going to cancel out, so I no longer have a negative there. X. And here, this is not really that important, so even if I got it wrong, I don't think it'd be a big deal, but I think it is 7. Luckily, this one looks like it's mostly in order already. Negative 3 is I'm going to divide all of those by negative 3. So negative 3 divided by negative 3, that gets rid of it, so we have y. Now I'm going to just switch the place of both of these numbers. So negative divided by negative is positive. 4 over 3 x. So again, I got to make it look like y equals mx plus b. If it's not in that order, I'm going to have to switch it. Now, since they're on the same side, I can just switch the placement. I can switch the order without having to do something like minus on both sides or add both sides or anything. If they're on the same side and you want to switch the order, just move them. That's all you got to do. Now, when you move them, you also got to make sure you keep the sign the same. So in this case here, 9 divided by negative 3, that's going to be negative 3. And again, that last number is not really that important. It's not going to help us determine whether they're parallel or perpendicular. But in this case here, 4 over 3x, 4 over 3x, they are parallel because they have the exact same slope. So again, same slope means same, same slope means that they go in the same direction, and same direction means that they are going in, they're not going to be moving away or towards each other. They're just going to stay the same distance away from each other, wherever. Okay. Let's see what we got here. Looks like I'm going to have to, I'd like to divide everything by 8. I don't know if that's the best idea to do this. Let's stick with the way we normally do things, and I'm going to put it in order first. So I'm going to add 8x to both sides, and here I get 8y equals 8x, and I'm going to divide both sides by 8. Move that up a little bit so I have more space, and divide by, come on, pencil, it'll be like that. Divide both sides by 8. So I get y equals x. Now in this case, my slope is just 1. It's just 1, my slope is just 1. So even though there's no number in there, it still has a slope. It's up 1 over 1. Now for this one here, I'm going to add y to both sides, and looks like I'm also going to have to minus 4 from both sides. And again, I'm just doing this to save space. I got a little bit of space to write in. I think if you're writing in your packet, your handwriting is going to be a little bit better. And I'm going to switch sides. So in this case here, I have y, right there, y. And 4 minus 4 is nothing, so there's nothing else on this side. And y is canceled from here, and I get x minus 4 left over. And in this case here, they both have a slope of 1. So slope is 1, slope is 1. That means they are parallel. And with this last one here, well, okay, so if you can, you can also graph it. So graphing it, x equals 2, y equals 2. So y equals 2 and x equals 2. All right, so in this case, I had a different graph on here already. So if I push the home button, I go back to the middle of the whole graph. And I can see that I have one line going straight up and down and the other going straight sideways. And if I put a piece of paper in that corner, on any of these corners, it's going to match edges, it's going to match the edges perfectly, align perfectly. So we know that this is perpendicular. And that's kind of a tough one because in this case here, it doesn't really give us a slope that we can look at. Okay, if we had something like say 2/3 and negative 3 over 2, then that would also be perpendicular as well. But in this case, we don't really quite have it that same way. Okay, so I guess there's a little bit more. I'm not sure how much further we can get with this, but we'll go as far as we need to. I think there's only one more page left, although I'm not sure if we'll be able to get through the whole thing. So x and y intercepts. So intercepts is basically where they cross in an intersection. So here we have an x-axis, right? So where it crosses right there, that crosses at -3, and the y-intercept got to go on the y-axis, and it looks like it crosses at 4. And it looks like we already did that, so it's going to be ordered pairs. So the first ordered pair is the x-axis, so x equals -3, up 0. So back 3, and that's it, just back 3, no up and down. For the y-axis, so usually your x number is the one that goes first, so no sideways, up 4. And for these, we also have some different words too, so you might have a couple of different words. So roots, solutions. I'm not sure what else. Was a 0 is the other one, 0. Roots, 0, and yeah, solution is one, but I'm going to put solution down here because it looks like this one's a little bit longer than the other ones. So I'm pretty sure that's where they would have wanted us to put solution. And when you get to other types of functions like parabolas, hyperbolas, and those sort of things, your x-intercept is your solution. That's like what you're looking at. So if you remember earlier when we were working with absolute values, and I think we were working with radical expressions too, you end up with 2 possible solutions. Yeah, that is something that happens because if you have a quadratic, you're going to end up with a parabola, and it's going to cross twice on your x-axis. Same is true with both absolute values and the radicals. Sometimes radicals can do that, but sometimes they don't. Okay, so there we go. That's how you do that one. You can also find them algebraically. Now for this one, I'm just going to save these for the exercises. But you basically just make the numbers x and y take turns being 0. So when x is equal to 0, you will find the y-intercept. If you make y equal to 0, you will find the x-intercept. So again, let's go ahead and practice some of that. And that's pretty easy once you get the hang of it. So just out of habit for me, I always find the x-intercept first. So I'm going to go ahead and set y equal to 0. And it looks like I'm going to have to add 1 to both sides. And I'm just solving for x now because x is the only thing there is. So in this case, 1 equals 5x. Divide both sides by 5. So I want to get that x again all by itself. And I'm going to use my reflexive property. So 5 cancels. That leaves me with only x over here. So x in this case is equal to 1 divided by 5, which if you use a calculator, and I think it's a lot better to use a calculator in this case. And for some of these, we are going to get repeating decimals, but just ignore them, okay? Just ignore them. And I know it's kind of very small and very fine. So I'm going to mark out 0.2 right there. And now I'm going to go ahead and find the other side, the y-axis. So where it crosses the y-axis, the y-intercept. So in this case, x is equal to 0, and this is usually the easier one. 5 times 0 is 0. 0 minus 1 is -1, so y equals -1. Right? Because 0 times anything, including 5, is going to be 0. So y equals -1. Now I notice with most of these examples, you don't really have a whole lot of, if they were a little bit wider apart, you could be more sure of your line's slope. So with this, it could look a little bit shallower, a little bit steeper, okay? But for the homework, as long as it's facing in the general direction and as long as your line goes from the bottom edge to the top edge or whatever edges you're going to, right? Side to side, top and bottom, whatever. Your line has to go all the way across the window of the graph. And for this one here, I'm going to do the same thing. So y will equal 0. 0 equals negative 6/5 x plus 2. Now in this case here, since this x is negative, I think it'd be easier to add 6/5 to both sides. Sorry, excuse me. So 6/5. Oh yeah, I should also take the x with it too. 6/5x equals 2. And I got to get rid of this 6/5. So I'm going to multiply it by the reciprocal. So instead of 6/5, I'm going to multiply it by 5/6. 5/6. And that should cancel it here, cancel it here. X equals 2 times 5 is 10. And 10 divided by 6. Now in this case, again, I'm just going to use a calculator, but I get 10 divided by 6, which I know is going to be a decimal number. So it becomes 1.6. And again, decimal, it's like 1.66666 repeat. But you know, I don't need to be that exact precise on the graph. We don't need that level of precision. There you go. That's a better way of saying it. Because this graph, again, it doesn't need to be that great. It doesn't need to be that precise. Now for this one here, y equals negative 6/5 times 0 plus 2. And y equals 2. Okay, that one was a lot easier to find than the first one. So just mark out 2 and just do your best to join those 2 points together. And again, so some of them, with points this close together, it's really hard to make sure you're pointing it in the same direction. Make sure you're pointing it in the exact same area or whatever. Move my calculator off to the side. And you're also supposed to, I think you're, let's see, it says find the x. I didn't put the instructions on this one here. It says find the x and y intercept and then graph it using those intercepts. So I'm going to hurry up and do that really quick. Now this shouldn't take that long, so let's go ahead and write up our 2 intercepts. So we know that the x is going to be 0.2, comma 0. And the y value is going to be, okay, so we have nothing in the x, but the y is negative 1. So again, not really that tough. So for this one here, the x is 1.6. Now I should say 1.6 repeat, but I don't have the repeat symbol ready to go. And here it'd be 0, 2. So yeah, for this one, you know what, I'm not going to be super picky about that, okay? But if you can, write the little repeat bars on top. Okay, now I know there are quite a few left to go, but I don't know how we're doing on time. I started a bit late, so I'm not exactly sure what it is. But let's do some of these that are a little bit more challenging. Okay, number 3 looks like it would be pretty challenging, so let's go ahead and do that one. All right, so same thing. Now I'm going to kind of reverse this because I noticed that looking for the y is usually a little bit faster, I guess, fewer steps. You know, no, never mind. I'm not going to change anything. Not going to change anything. Let's just keep things the way they are. Even though I think it'd be, I don't know if it'd be easier to follow or what, but there you go. So y is equal to 0. Add 3x to both sides. And I get 3x equals 16/3. Now I got to multiply both sides by 3. Because I got to get this 3 to cancel. I got to get rid of my fractions. And it's the same thing. If you remember when we were multiplying all the fractions by a certain number, It's practically the same thing. Now, the reason I didn't multiply this, well, I guess I could have used the reciprocal trick. But in this case, I know there was one of these that you can't use the reciprocal trick on. And I don't remember if it was this one or it might have been another example. So divide both sides by 9. So I had it backwards. So in this case here, 9 should be the bottom number. All right, I was out of space, so I thought I could save some space by not putting the line under 9 and that stuff. So there you go, 16 over 9. And again, I'm going to use my calculator because I don't need, 16 over 9 isn't going to do me a whole lot of good. So in this case here, my first one is 1.7. So I need to mark that part on the graph. But let's go ahead and do this one here. And that is, this is going to be 0, and y equals -3 times 0 equals 16 over 3. Well, 0 times anything is just going to be 0. And 16 over 3, now this one I think I do know, it'll be 5, because it'll be 15 and 1/3. But I'll just say 5.3 for this one here. So I'm going to make this one look more like a comma because that one is the comma. Wait, no, 5.3. This one's the comma. What am I talking about? Now with this, we should have enough. So 1.7 is just a little bit under 2, and 5.3 is a little bit above 5. And again, it's probably easier to just go on your own graph and look at it and see what works best. Because if you try to follow exactly what I did, it's going to be a little bit harder. I don't know how tough it is, maybe. Maybe it's not that tough. Now, this one is in standard form. So if it's in standard form, that makes it a lot easier because when they take turns being 0, we don't need to add or subtract to both sides. So this is why when we graph in standard form, we put it in that form of ax plus by equals c. So if I want to know what if I want to know what this is, it would just be 4x equals 8, right? Because minus 0 is not going to change anything. I mean, I could write it out. 4x minus 0 is still going to be 4x. And x equals 2. Because I just, 2 times 4 makes 8. So I already know what you have to put in there for x. So that was a lot faster. Let's go ahead and do this one here, y. So negative y, because 4 times 0 is just 0. So it's not going to change anything. So all I have to do is grab the negative y and put that in there. Divide both sides by -1, and there we go. X is equal to 2, and y is -1. So let me go ahead and put that in there, and I'm going to type it out this way. I don't write commas or dots mixed up again. So first one is 2, 0, and the next one is okay. So the -8 goes in the y. So x is 0, and -8 is the y. Okay, so over 2 and down 8. So 8 is going to be, I think it's that very bottom one because I think this graph goes to 8. Bam. Okay. There we go. We're done with that one. Moving on to the next one. That one was a pretty easy one. This one is another one that is in standard form, which again makes it easy for us to find the intercepts. So when that happens again, you can just ignore that entire term. So if I want to find y equals 0, just ignore it. -4 times 0 is just going to be 0. 5x minus 0 is still going to be the same number. It's not going to change it. So it doesn't change in that, but in this case here, this would still be the same. And if I were going to do the same thing with 5x is, where x is equal to 0, -5x times 0 is going to be, well, nothing. So I just ignore that. And again, you can write it out. Nothing wrong with that. So when in doubt, write it out. but I'm going to do this one a little bit faster. All right, so again, just divide both sides by this number here, by -5. And let's see, in this case, I get 4.8. And again, you can use a calculator for that if you want to, but in this case, I so happen to know that it is just 4.8. And in this case, this would be 6, positive 6. And there we go. Now I can type out my ordered pairs for those intercepts. So 4.8 and 0. And y, so there's nothing in the x. That's how you know it's the y-intercept, 6. Now I can graph these points. So over 4.8, up 0, and y, and you can look at this and say y-axis is 6, or you can look at your ordered pair and go, okay, don't go sideways, just go up 6, something like that. And once you have those two lines and graphed well enough, just do your best and draw a straight line through them. Again, you might use a ruler. You can probably also use something like a credit card or your student ID. Okay, something as long as it's usable. And for this one here, I'm going to go ahead and get this, and I'm going to do the same trick. I'm going to times everything by 12, because 12 can be divided by 4 and it can be divided by 3. And I'm only doing this to make it easier for us to ignore the numbers, sorry, the fractions. So 12 times 3 is 36 divided by 4, so that'd be 9x minus, and then 12 divided by 3, or 12 times 1/3, or 1/3 of 12, is 4y minus -24. There you go. And I'm going to do the same thing. It's already in standard form, and that makes it really easy for us to ignore one of the numbers. So I'm going to ignore y, so 9x equals -24. And I'm going to ignore the x now, -4y equals -24. And don't forget, this is also just review mainly, right? Because this is mainly just review. You would have covered most of this stuff in algebra 1, which again, it's different. Some people may not remember anything from it, so that's why we're covering it now, because you're going to need most of this information when we cover different functions. So different things like parabolas, hyperbolas, and other things like that. So in this case, I don't know what this one is off the top of my head. So 24 divided by 9 is 2.6. Now it's supposed to be 2.6666 repeat. But again, my graph is not going to be that precise. So for this one here, 24 divided by 4 is going to be 6. And it's negative, so it's going to be negative divided by negative is positive. And I'm going to type out my ordered pairs again, just so it doesn't come out to be anything weird, because this one has a comma and the decimal. So there you go. I wrote out my ordered pair here. So over 2.6, up 6. Sorry, it's a little bit smaller on my screen, and again, it's probably small on your screen too. But as long as you follow those, you should be able to get them. And I think I have enough time for one more, and that will actually be the last one. I'm not sure how the timing is going, but we'll finish this one. Now let's see what happens if we don't use the division trick where you get rid of your fractions. 5 over 2x equals 6, right? So y is equal to 0, so I ignore that one. And for this one here, 5 over 2 is the 0, so 0 times anything is going to cancel that out. So I just ignore the x. And just so these things don't get confused, I'm going to go ahead and put a line there. I should have given myself some more space on this, but I'm going to multiply both sides by 2/5, because 2 times 5 is 10, 5 times 2 is 10, 10 over 10 is 10 divided by 10, which is 1. And 6 times 2 is 12. And 12 divided by 5. So 12 divided by 5. Now, I should have known that one. But it would be 2.4. And for this one here, I'm going to have to multiply both sides by 6. Now, if you don't want to use the reciprocal trick, you can always just do one at a time. So in this case, I'm going to multiply both by 6. So that gets rid of this fraction, and I get 5y equals 36. And divide both sides by 5. And that gives us y equals, let's see, 35. So 35 divided by 5 is 7. And it looks like I have 1/5 left over, so that'd be 7.2. But I'm going to double check that on my calculator. 36 divided by 5 is indeed 7.2. So a little bit above 7 and a little bit past 2. Oh yeah, and we should also put our ordered pair into a, I'm sorry, put our intercepts, x and y intercepts into ordered pairs. 7.2. So again, when you write out the ordered pair, one of them's x is going to be 0, the other one's y is going to be 0. Because again, remember what we did is we plugged in 0 for either x or y and then solved, or I should say in this case, yeah, solved for both of them. So it's still a function, just like we did yesterday with inputs and outputs. If I put in 2.4 into this equation, I get 0. If I put in 0 into the equation, I get out 7.2. All right, and that's it for the packet. I think that is it for today. As always, if there's any questions, I'll be around for a little bit after the, okay, don't wait around then. But as always, I'll be around. See you tomorrow.